Hello, students. Welcome to part 2.
Hello students, in this part we are going to learn to determine whether a function is linear or not from its equation. Now you do always have the option of graphing the equation and using those characteristics to decide whether it's a linear function or not. However, if you can learn to identify standard form or see your parent graph equations within other equations, then it will help you and be a lot quicker in deciding if an equation is linear or not. So when you're identifying a linear function using its equation, way one is to graph the equation and follow the steps outlined for graphs. In other words, create an input-output table and graph the ordered pairs. Way two, however, allows you to ask yourself a yes or no question. Can the equation be written in standard form? Now, standard form is when you write the x term and the y term on the same side of the equation and it equals a constant. And that constant can be 0, can be a fraction, can be a decimal, anything. But you can see what the form looks like. Ax, a number times x, plus by, a number times y, equals c. Now, a little bit more information about standard form. Here's the big idea. If an equation can be written in the form ax plus by is c, then it is a linear function. Your parent graphs y equals x and y equals 1 fit this format when you rearrange them. And you can understand that because if you graph them, y equals x passes the vertical line test and is a straight line, and y equals 1 is a horizontal line and likewise passes the vertical line test and is a straight line. You could also write them in this form. If you took away x from each side, you would have negative x plus y equals 0, and you can see that the x and y terms are on the same side equal to a constant. Here, it's a little bit different, but you could think about this as no x, 0x, plus 1y equals 1, and you can again see that the x and y terms are on the same side of the equation. Now, here are some notices that can help you understand standard form and quickly identify whether an equation is linear or nonlinear. Notice x and y both have exponents of 1, which makes sense because if it had an exponent of 2, it would create a U shape, or 3 would create that cubic shape of your parent graph. Notice x and y are not multiplied together, they are in separate terms. And also, x and y do not appear in the denominator, they're both in the numerator. There can be fractions in front, but the x and y themselves have to be in the numerator. We also, again, see no exponents, and we see no square roots or absolute value symbols because we know that square roots would create that hook shape, and the absolute value would create that V shape. Now, let's look at some equations and work to identify whether they would be linear or not based on their equation. So here's the first example. We have y equals x plus 3. And remember, if we can write it in standard form, which is ax plus by equals c, then it would be linear. And we know that there are two parent graphs, y equals x and y equals 1, that are also linear that can help us. We can also look at our no list. We know we can have no exponents, no absolute values, no square roots, no x or y together or in the denominator. Now, go through our list. Are there any exponents in this? No. Any absolute values? No. Any square roots? No. Any division of the variables? No. Are the x and y in the same term? No. So we meet all of the requirements of being in standard form. And if you look at this, if you look right here, you can see y equals x. It's just that it's been shifted 3. It's 3 more than y equals x. So this is a linear function. We could also rearrange the equation by subtracting x from each side to get negative x plus y equals 3. And that would be standard form. A number x plus a number y equals 3. Now, let's look at another example. We have y equals x squared. Go through our no list. If it's linear, it can have no exponents. Well, there's a problem because there we see the square. And you can also think about your parent graph, which makes this U-shaped. So it is a function because it passed the vertical line test, but it's not linear because it's not a straight line. So it's a nonlinear function. Oops, sorry. All right, let's look at another example. We have y equals the absolute value of x plus 2. So go through our no list. Does it have no exponents? Well, that's good. No absolute values? Well, it does. So we know that based on our parent graphs, this is going to create a V shape, which is a function, but it's nonlinear, not a straight line. What about y equals 5x plus 9? Well, you can see our y equals y equals x equation within this. It's just that x is being multiplied by 5, it's constantly going up by 5, and being decreased by 9. So this would create a linear function, and we could write this in standard form if we wanted. If we took this and we subtracted 5x from each side, we'd have negative 5x plus 1y equals negative 9, which fits the standard form layout. So this is an example of a linear function. What about y equals x divided by 3? Let's go through our no list. No exponents? Well, that's good. No absolute values? That's good. No square roots? That's good. No division of the variables? Well, we see division of x, so that automatically makes this a nonlinear. Okay, so let's practice sorting some more equations as linear or nonlinear. Here's the first one. 3x plus 2y equals 10. This would go in the linear category because it's already in standard form. What about 3xy plus x equals 1? Well, this would go in the nonlinear one because x and y are in the same term and they cannot be multiplying each other if it's a linear function. What about x plus 6 divided by y equals 12? Well, since the y variable is being divided, it has to be nonlinear. What about y minus 2 equals 3x? This is linear because we have y equals x. We have no exponents, no absolute values, no square roots, no division of the variable. X and y are in separate terms, so this is a linear equation. What about x cubed plus y equals negative 1? This would be nonlinear because we get that cubic shape of our parent graph. And negative y equals 5x. Here we see y equals x, so this is a linear function. So let's review what we've learned. We've learned that a linear function is a function whose graph forms a straight line. We've learned that a graph is a linear function if it is a function which we can determine by the vertical line test and it's a straight line. We've learned that a set of points is linear if they form a linear function graph or a constant pattern is evident in the ordered pairs. And last, we learned that an equation is linear if it creates a linear function graph or if it can be written in the form ax plus by equals c, which we know is called standard form.